Okay, well, good afternoon, everyone. It's a pleasure to be here at the Jefferson Society. It's also nice to see some familiar faces as well as some new faces. Let me get the clicker here. I'm excited to be your Earth Day speaker, and I'm talking about one of the subjects that I'm most interested and most passionate in, and that's the subject of aquatic invasive species in the Great Lakes. As the introduction stated, throughout my career, I've had the opportunity to discover, rediscover, and to see firsthand the impact of a number of these species in the local environment. And it was, I'm always excited when I have an opportunity to share some of what I find is a fascinating invasion history in the Great Lakes, which of course with an emphasis on Pennsylvania and the Erie watershed in particular. So as you look at the title slide here, these are all species that I've personally collected or documented as new range expansions in Pennsylvania, things like the European rudd. Well, the big guy in the middle there, that's a grass carp. So that's a species that can be intentionally stocked in Pennsylvania with a permit from the Fish and Boat Commission, provided that it is not reproductively viable, a condition we call triploid. It's a genetic condition. However, that process of making the fish triploid, we're all diploid. We have a copy of chromosomes from our mom and our dad. So these fish would have an extra copy that prevents them from successfully reproducing, except that life finds a way, one of many Jurassic Park references that you'll hear throughout my talk. Life does find a way, and these species are, in fact, reproducing in Lake Erie. So this was a 69-pound, 48-inch fish that was collected from Presque Isle Bay. Fishermen in the audience, you know the old fisherman trick of you hold the fish out as far as you can and close to the camera to make it look bigger. That was not the case here. I was doing my best to hold this 69-pound fish. All right, so without further ado, let me tell you a bit about a story. And I'm increasingly interested in history and, some feedback from that mic maybe. Walk this way. So I'm increasingly interested in history, and I think that the history of biological invasions in the Great Lakes is absolutely fascinating. So I want to tell you a story. But before I tell you the story, I'd just like to kind of scope out my topics, set some ground rules, if you will. So before I start with the story proper, I want to talk about the history of the etymology or the naming of what are now known as non-indigenous invasive species. And my specialty, my focus is aquatic invasive species, in particular fishes. So it's going to be a bit of a fish-centric presentation, so I apologize now. But the concept has evolved over the years, probably starting with the concept of weed. I mean, I think we all know what a weed is, and a lot of people would consider a number of weedy species to be invasive species, and I would agree that they are. And then we talked about alien species or exotic species or aquatic nuisance species. It's actually a term of art in legislation that established that Great Lakes panel on aquatic nuisance species. But we've come to really be a little bit more introspective about the way we describe these species over time, because while there is a kernel of truth and a kernel of utility to all of those different terms, there's also some negative connotations and some negative consequences associated with these terms as well. So, you know, native, non-native, invasive, these are terms that are important. So here's an example. I'm guessing that a lot of folks in the audience have seen signs similar to this, with kind of using the old Western wanted dead or alive motif when it comes to invasive species. And oftentimes we see that they're wanted dead, not alive. So there's a utility, there's a benefit, there's a selling point, right, to capturing the public's attention by talking about the least wanted or the most dangerous or the wanted dead, not or alive species. But there's a downside as well. And I think sometimes it can not serve us from a scientific standpoint or from a societal standpoint. So there is increasing sensitivity to really think about the way we describe these species. What I hope that you get from this talk, if nothing else, is that there are no bad species. In fact, a lot of the organisms that we call aquatic invasive species are fascinating creatures. I maintain a fascination with these organisms to this day. They have unique traits that, when combined with a novel, new recipient environment, allows them to become extraordinarily successful. And the Great Lakes, I was, as I thought about how to shape this talk a bit, it occurred to me that this is, and it's not my idea, but I agree with it, that the Great Lakes are the most invaded freshwater system in the world. So we live in such a unique area for so many reasons. And another unique aspect is that we live in the most biologically invaded freshwater system on the planet. So just like Grandpa used to always say, everything in its place, a place for everything. It's not that the species are bad, it's that bad things can happen when they are transported from their native home regions to a non-native recipient region. All right, so an example here, there's the pointer. So of the naming convention, other than the militaristic, notions for all of these species, we have, a naming convention that seems to make sense at first, which is talking about the native range of the species like Asian carp. There's probably other examples here, but that's not always accurate. And a lot of species that we would consider to be naturalized in North America we're not necessarily are also Asian or European or Pondo-Caspian or from various parts of the world, and the terms that we apply are not always accurate. So I just wanted to raise that thought. There's increasing attention to the way we describe these species. So remember back in, I guess it was 2019 or 2020, as we were dealing with the outbreak of COVID-19, in Washington, they discovered what was called at the time the Asian murder hornet. So who can remember, who can forget hearing the first time they heard about the Asian murder hornet, right? As if COVID wasn't bad enough. So at least we've moved away from murder hornet to giant hornet, but there's still the implication. You can imagine if you're of Asian descent, well, why is this bad? I grew up with this species, or I grew up eating this fish. So there certainly is an unintentional, I think, negative connotation that can co-occur with the way we describe these species. And in addition to kind of militarizing invasive species, we also sensationalize invasive species. So here we have, something, a poster that could have been in a science fiction movie. Maybe you've seen some science fiction movies about invasive species like snakehead terror or frankenfish. So again, I mean, there's a utility to this. It gets your attention, right? It's more exciting to talk about the killer shrimp than it is to talk about Dicryogamorus. But there's also a downside. Here's an example, I hope. How many people in here have heard of the spongy moth, a very important invasive species? Really? The spongy moth? You have not? How many people in here have heard of the gypsy moth? Well, if you didn't like the gypsy moth, you'll equally not like the spongy moth because they're both Listeria dispar, it's the same species. So this is an example of, in this case, the Entomological Society of America, trying to be sensitive, culturally sensitive in this case, to the common name used for a species. This is the same tree-devouring species. It's still highly problematic in North America, but now it's commonly referred to as the spongy moth, if you look it up. So just an example of how we are starting to move away from some of the more pejorative terms. There's a downside to that as well, especially when you, we'll leave it there. Okay, so the subtitle of my presentation is the world's most invaded freshwater system. So let's get to it. Let me prove to you that it is, or hopefully have you consider how invaded it's been. So this is the result of work by a colleague of mine that works for NOAA. I think she's with Michigan Sea Grant as well. She's done a fantastic job of cataloging non-native species throughout the Great Lakes. There was some work done back in 1993 that opened a lot of our eyes about how many species were non-native. Rochelle Sturdivant and her colleagues have added to that, and here we have it. 28 different species of non-indigenous fishes are established, and that is that they have reproducing populations. in the Great Lakes. 18 species of mollusks, things like snails and clams. 24 species of crustaceans, 19 other that are mainly aquatic worms of various varieties. We also have non-native microbes, non-native pathogens, viruses, protozoa, algae, which is kind of a loose term in and of itself, and plants. So just be aware that these are non-native species, and it's more than just fish, even though that's what I'm going to talk a lot about today. And I'm only going to scratch the surface of this list of 189 species. And one reason is time constraints, obviously. But another reason is that the vast majority of the non-native species that now occur in the Great Lakes are not, either not harmful or they're beneficial. So just because you're not from here doesn't mean that you're harmful. Okay, so about a third, as a rule of thumb, about a third of the introduced species have been problematic. As you'll see, some of them have been and continue to be hugely problematic. Another third, there seems to be no obvious harmful impact from them, no obvious impact. I mean, if you're what we call in biology a niche competitor for one of those species, you may disagree. And for the final third of this group of 189 species, aquatic species, we just don't know. There's just not enough information. So what I want to talk to you today about is that subset of non-native species that are known as aquatic invasive species. All right, so just so we are on the same page, and we can even disagree about what's a harmful species or a non-native species, but just let me operationally define it for today's talk, just so we're on the same page. So I'm going to use the definition that was first proposed back in 1999 by Bill Clinton. He issued an executive order called Executive Order, was it 13112, Invasive Species. And among other things, it established the National Invasive Species Council, the first time that all federal agencies were required to work together to deal with this issue. It established the requirement for a National Invasive Species Management Plan. Those are both very important things that have proven to be very beneficial. It also specifically defined what we meant by an aquatic invasive species or a nuisance species. It still had some old language, as you'll notice. It talks about alien as opposed to non-indigenous. But the concept is as follows. Whoops. I'm sorry if I just shot someone. So this is the definition that I'll be using when I talk about invasive species today, or alien, which is to say non-indigenous or non-native species, whose introduction does or is likely to cause economic or environmental harm, because those are both some of the harms that are caused by aquatic invasive species. There's also potential harm to human health, and you might think for a minute, well, how can that be? Well, you can think about non-native diseases that are transported along with their host species. Things like VHS, viral hemorrhagic septicemia. This is a non-native virus that proved to be very, very detrimental when it was introduced into the Great Lakes. All right, so there can be a human health impact as well. So the two key components of what I want to talk about today is that it is non-native, it's non-indigenous, so we can have native species that can act in an invasive fashion as well. But there has to be that harm, whether it's ecological harm or economic harm. Okay, just so we're on the same page. Okay, so I bet there are some fisher persons here in the audience, and a question that I always get, and it's a fair question, is why would I not want to have a new big sport fish, something I can catch in my backyard? It's exciting. Some of these species are very charismatic. Some of them, you know, some of them are apex predators. They're fun to catch. Snakehead come to mind. Well, here's the reason. I'm going to make everyone. I spent a lot of time in class learning about ecology, but I'll make you all ecologists in just one slide. Okay. So the first thought here, it's what I call the first and second law of ecology. They aren't really laws, but there's some truth to them, and I think that they're useful. So the first law of ecology, in Ecology 101, is that everything affects everything else, right? And this is a lesson that we see time after time after time in ecology or environmental biology. And an easy way to think of it is like this. Think about the ecosystem as an interconnected, intertwined net. You can't tug on one end of a net without moving the entire thing. So the ecological impacts of new species introductions are often very complex. They're often not just difficult to predict, they're impossible to predict. And I've got some examples of that. Okay, so that's the first law. So everything affects everything else, usually in unpredictable ways. And the second law of ecology is there is no free lunch. And I think we've proven that here today. What was the cost of the lunch today? $5? And they have to listen to me. All right, so there's no free lunch. And this actually does stem from a very well-accepted, well-understood biological principle. It's called competitive exclusion, or Gauss's law. And the idea is, sometimes it's expressed as no two complete competitors can coexist. The idea here is that there are only so many resources in the environment, whether it's food, whether it's habitat in which to live and reproduce. And if two organisms are utilizing that exact same resources, that exact same niche, we call it, then one will be favored over time. So then in response to the question, why wouldn't I want this new exciting species of fish, let's say, that's fun to catch and maybe is good to eat and has certain benefits, my response would be, well, which one of your native species would you potentially sacrifice to support that new species? And I think that's the downside. Here's an example. This is a lake whitefish. So this is the intertwined net. And the lake whitefish, it's a native salmonid. It still exists in Lake Erie. Numbers wax and wane. A closely related species, the Cisco, or lake herring, you may have heard it referred to as, is gone. All right, so again, this is not entirely due to, but is likely partially due to the introduction of non-native species. Okay, so that's just kind of the answer to the question, why should I care? And then if you don't care about the ecology, or if you're not particularly a sportsman, well then what about the economic impacts of non-native species? Again, the economic impacts they're difficult to wrap your head around. Estimates vary, but they're surprising. Okay, so economic impacts. The first thing that you might think about is that, well, one fish eats another, and we've seen in the case of a group of fishes previously known as Asian carps or big-headed carps, they've led to complete eliminations of fisheries in the waters where they occur, which hopefully doesn't include the Great Lakes currently. But that's an obvious example of, well, now we can no longer maintain our livelihood because of this new introduced species. But there's so many other impacts as well that are more difficult to predict. What about the occurrence of a new aquatic plant on your property along the lake in which you live? Can it decrease your property values? What about tourism impacts? If we have these large fishes that could jump out of the water and possibly harm someone, is that going to discourage folks from visiting Erie? What about disease outbreaks that may be in part a result of the introduction of new non-native species? So what about costs, control costs, for a simple example, to use here in Erie, Pennsylvania? I should have checked with the Erie Waterworks previously, but I think they spend somewhere between $50,000 and $100,000 a year just on the chemicals, the chlorine, the bleach, that's needed to disinfect the water intakes for the city of Erie, just to keep water flowing. Okay, and that's because of the zebra mussels, which are one of the featured species that I'll talk about. So again, very surprising impacts, control costs, cost to taxpayers to have people like me deal with non-native species. So all sorts of economic impacts. It's really difficult to kind of point to numbers other than with certain, like it costs about $20 million to control the sea lamprey, which is something I'll talk about annually. That ultimately is borne by taxpayers. It's difficult to get accurate numbers, but current estimates range from, say, $100 million to maybe $5.7 billion each year. When you think about the total incidental costs of having new species invade that are destructive. So it costs us money. All right. Okay, so now I was trying to set the stage a little bit, as is my habit. Now I'd like to tell you the story. So the story of biological invasions in the Great Lakes can be thought of as different waves. And this again, I'll credit my colleague, Rochelle Sturdivant, for this. But let's talk about the 3 waves of invasions in the Great Lakes. And our story is going to start with the completion of the Erie Canal. So the Erie Canal was opened back in 1825. As a reminder, the canal connected Lake Ontario, Lake Erie in Buffalo with the Hudson River. And in 1825, October 26th of 1825, if I recall, Governor DeWitt Clinton boarded the packet boat, the Seneca Chief. And for the initial opening of the Erie Canal, this engineering wonder that allowed for commerce, between the Atlantic Ocean and the Great Lakes and inland into the country. So along with a lot of pomp and circumstance and fanfare, Governor DeWitt had 2 wooden barrels of water from Lake Erie aboard the Seneca Chief. And it embarked on its journey down the Erie Canal, reaching its destination in New York's harbor about a week later. There was some more pomp and circumstance and fanfare, and eventually the Seneca Chief made its way back to Buffalo, New York. And by the way, whoops, I'll go back there. And by the way, if you've been to the Buffalo, I think it's called Canal Side, the Buffalo waterfront, you can see these signs today in Canal Side, which is where I got these. But so when the Seneca Chief returned to Buffalo, to much less pomp and circumstance because the governor had disembarked, it contained a couple kegs of water from the Atlantic Ocean, and they were dumped into the Great Lakes. So there we go. There was the first likely introduction of non-native species into Lake Erie. All right, so in addition to canal building, there were a couple of other primary methods of introduction in the first wave. One was intentional introductions by European settlers, right? So they brought with them the species that were beneficial and useful or enjoyable to them. It could be ornamental species, it could be food fishes, things like the common carp that had become established throughout the world. There were intentional introductions. Let's see, solid ballast. This is an interesting story. So I'm going to talk about ballast water later. I think I'll hold off on that. But this first wave of introductions it resulted in a rate of new species introduction of about 1.05 per year for the period, I keep on advance, in the late 1900s. Okay, so the first round was intentional or unintentional through the construction of canals. Okay. So here's a good example of an intentional introduction, and the reason that this gets an asterisk, does anyone know what this species is by chance, or have you seen this around? It's pretty. Yeah, exactly. It's purple loosestrife, and it really is a very nice plant. So you'll see it. You'll see people still intentionally move it around and plant it. It's semi-aquatic. It likes damp conditions, if nothing else. So it was brought over as an ornamental plant, but there's also another really interesting way in which it was introduced into the New World, and that was by what was called solid ballast. So we'll talk about the need for ships as they transit the ocean, the Atlantic Ocean in this case, from the Old World, to stabilize the vessel by adding ballast water and some of the problems that are associated with that. But back in the days of the wooden sailing ships, before they had the ability to pump water in and out of ships, they simply filled them with soil or small gravel, other things that could be easily shoveled in and out of the vessel. So you're loaded down with settlers or with cargo from Europe, or you're taking on cargo in the new port. So you stabilize the vessel with the solid ballast, and then you're taking on a load of cargo or passengers or whatever it may be. You need to get rid of some of that ballast, right, to kind of maintain the weight and the balance of the ship. So they simply shoveled it out. And all the seeds that were in the seed bank of that solid ballast were also kind of introduced into North America. So that's an important way that a lot of plant species from Europe were introduced into North America, was by the kind of shoveling out the solid ballast. All right, so plants are important. I'm a fish biologist, so I'm a little bit fish-centric. So other intentional introductions, I already mentioned the common carp. That's the handsome one in the front. And the goldfish, yes, when you release goldfish into the water, they really do keep growing. They don't grow, well, all fish have indeterminate growth, but they grow large. And at least they're often, these bright, colorful, giant goldfish like you might have in your aquarium at home. It's always kind of a circus when we're doing our work as biologists and we see a non-native goldfish. Both of these species hybridize. Interesting fact about both of these species, the common carp, as you all know, is the largest minnow in Pennsylvania. So that's a Cyprinus carpio, in fact, is its actual species name. So this is a minnow, this is a minnow. All right. Both of these fish were intentionally introduced. Some were released as pets because for humane reasons, although there's an inhumane impact sometimes. And both species can breed. They can make hybrid fishes, very common in the Great Lakes. But they can be also very problematic. A lot of people would argue that the common carp, which we think of as just part of North America, and it's not, hugely problematic. It can really alter entire ecosystems. Okay, but the thing that I really want to talk about as far as the first wave of invaders was the sea lamprey. So the sea lamprey, again, you'll see my admiration of these species. These are not bad species. These are species that have sometimes amazing life histories, amazing strategies to survive and reproduce. But this is a very primitive, oops, get back there. This is a very primitive jawless fish. So biologically, this and something called the hagfish, which is another lovely creature, they're the only two surviving taxa within the group known as Agnatha, or no jaws. So what they do is these primitive fishes, by the way, everything else, all other vertebrates are jawed vertebrates or jawed fishes. So we are all part of the clade Gnathostomata. So we're all jawed fishes, biologically speaking. These guys are super primitive. So now you know, if I haven't offended you yet, now I have, you're a jawed fish. So what these things do is they attach with this oral sucker, with this toothy oral sucker, to the side of prey fish. In this case, this is a lake trout, very important native top predator in the Great Lakes. And they'll actually rasp a hole in the side of their host fish with this rasping tongue, if you can imagine that. So these are really out of a science fiction movie. Even though I said I didn't want to be sensationalistic, I mean, I still, it captures the imagination. And unlike our native lamprey species, of which we have many, in fact, our native lampreys, most of them in Pennsylvania at least, are considered threatened or endangered. They're also much smaller. They're also not all parasites, and the ones that are parasitic don't typically kill the host fish, which the sea lamprey typically does. So really fascinating creatures. They'll live in tributary streams, in this case to the Great Lakes. There's only 3 in Pennsylvania where they're able to reproduce for 4 to 6 years. Then they'll transform. They look like little kind of worm-like things, and they just filter feed organic material out of the water column. Then in 4 to 6 years, they transform. They swim downstream into the Great Lakes. They become these parasitic adults, and they can consume up to 40 pounds of fish in their lifetime before returning upstream to spawn. So yeah, truly a fascinating critter. So the sea lamprey, they invaded through the Welland Canal, which is a reminder, the Welland Canal bypasses Niagara Falls, which is a pretty darn good barrier to the upper Great Lakes, right from Lake Ontario. But they invaded in 1921. They were first discovered in the Great Lakes. The Welland Canal was constructed back, I want to say in 1829, but it underwent a number of modifications, including, and it was expanded. It was expanded several times, and the most recent expansions seemed to be, for whatever reason, conducive to the movement of sea lampreys through the canal. So invaded the Great Lakes in 1921. By 1940, so what is that? Something like 2 decades later, the sea lamprey predation on things like lake trout and cisco and whitefish, along with overfishing by commercial fishermen, led to the decimation of these important fisheries in the Great Lakes. So to this day, the lake trout, this species, it was eliminated from Lake Erie. Some of you may say, well, wait a minute, I know that there are lake trout in Lake Erie right now. I may have caught one. So all the lake trout in Lake Erie currently, to our knowledge, are intentionally stocked by the federal government to kind of hopefully reestablish a reproducing population. And you can notice this, they've got a fin clip, they've got a coated wire tag in their snout, but they're not native. They're not the native strain that evolved in Lake Erie. All right, so this one invasive species, this first really hugely destructive aquatic invasive species that did certainly contribute to the collapse of commercial fisheries, it led to the creation of an entire binational government agency called the Great Lakes Fishery Commission in 1955, with the primary mission to exterminate the sea lamprey. They failed. The sea lamprey is still present today. So a common theme you'll hear me say throughout the talk is that, and this species still exists to this day. This is an example of a barrier. These pictures, these are all my pictures of sea lamprey that were collected from Conneaut Creek, which is a tributary of Lake Erie. Its mouth is in Ohio, the headwaters in Pennsylvania. And there's a dispersal barrier project that's being examined since last year using electricity to hopefully repel the spawning migrations of the sea lamprey. In lieu of an electric dispersal barrier, a chemical lampricide, it's known as TFM, is used throughout the spawning streams in the Great Lakes at huge cost, both economically and sometimes ecologically, to try to suppress the sea lamprey because they still have extreme adverse impacts on native fisheries to this day. So very interesting. Fascinating critter. Okay, so let's talk about the second wave. The second wave, this is a statistically identifiable increase in species introductions. It results in an increased species introduction curve or rate of about 1.5 per year. This would include escapes from cultivation. These are mainly plants that escape kind of agriculture or horticulture. It also includes species like the rainbow smelt that was intentionally introduced, in this case, to a tributary of Lake Michigan called Crystal Lake. It, of course, escaped immediately upon its introduction. And it has had beneficial and highly non-beneficial impacts in the Great Lakes as well. So I'm curious, honestly, if anybody recalls spawning runs of smelt locally. You do. You're able to kind of, as I understand, dip them out, and I know I've caught them certainly on hook and line. Their numbers seem to be very much lower in Pennsylvania, in Lake Erie today. You may also have heard of the potential relationship between the introduction of rainbow smelt and the extirpation of our local blue pike, which is just it was a uniquely evolved form of walleye in Lake Erie and Lake Ontario. These, as you can see, these are small. They're osmerids. They're small fishes. They can grow to be maybe 12 inches in maximum length. A lot of them are quite a bit smaller, the ones that you probably dipped out of the streams, I would think. But they're toothy little guys, and they were massive schools of smelt that would move through the lakes and just kind of chomp on everything that they could fit into their mouths, including the early life history stages of the blue pike. So they could have played a large role in the demise of things like blue pike. Rainbow smelt, other small non-native forage species, that's what fisheries biologists call everything that they don't stock as a forage species. So forage species like alewife, a non-native Atlantic fish. They also had a very other unique, unexpected, unanticipated trait, and that is that their bodies contained high levels of thiaminase. You might have heard of thiamine or vitamin, I think it's B12, I should have refreshed my memory on that. But basically, when our native fishes were preying on rainbow smelt and alewives, they developed, especially the salmonids, they developed a problem that would prevent them from reproducing called early mortality syndrome, EMS. So as a result of non-native species that were genetically wired to have an enzyme that degraded a vitamin that our native fishes needed, there are fishery level impacts. And those impacts, again, do occur to this day. I want to take a step back and think about the role of the sea lamprey and the impact that it, along with overfishing, we cannot leave ourselves off the hook, but the impact that sea lamprey and overfishing had on our native, commercially important fishes like the lake trout and the cisco and the whitefish. Those populations were decimated. Ecologically, they play a hugely important role in the ecosystem. They kind of keep the smaller fishes in balance, which in turn keep other things in balance. So without those top predators, things like rainbow smelt and alewives, which are small fishes, their populations exploded, right? And I just mentioned the unintended consequences of these fishes. That is a result of that, and part of the curve, this increase in stocking, were things like Pacific salmonids, like coho salmon. Again, I'm not saying coho salmon, is an invasive species, but it was intentionally stocked because our native top predators were gone, or ecologically their numbers were so small that they could no longer serve their role in the environment to suppress the forage fish population. So just an interesting aside about the second wave of invasions. But what I'd like to spend the rest of my time on is the third wave of invasions. And the third wave of invasions are those species that were introduced as a result of ballast water discharges. So this would be roughly the period of 1959 through 2006. There's a reason that it ends in 2006. As you can see, the invasion rate is increasing still to about 1.8 new species discovered per year. And here's the ballast water problem. This is an example of one of the ships bringing wind turbines into Presque Isle Bay. As this ship is offloading its cargo, as it does, it becomes lighter and it will be unstable when it goes back across the Atlantic Ocean if it doesn't take on more cargo. So it needs to take on ballast water. And here's the problem with that. All right, so the way ballast water works is when a ship is full of cargo or full of people, back in the old days, they used the solid ballast, right? Stuff they could shovel on board and shovel off. Well, then it became a lot more efficient to use water as ballast. You'd pump it on board and pump it off. So when the ship is full of cargo, you don't need to have ballast water. But when the cargo is offloaded at port, or when your passengers are offloaded, the ship becomes lighter, it rides higher in the water, and it would be unstable on the high seas in the open water. So the ship needs to take on ballast water. The problem is in that home port, whether that port is in North America or whether it's in the Black Sea in Europe, it's also taking on anything that's alive, living creatures, living organisms that are in that water. And that provides safe passage for those critters across the Atlantic Ocean. Most aquatic organisms, are not very tolerant of changes in salinity. So the ocean itself was a big barrier to fishes swimming, for example, from Europe to North America. But they're just happy to hitch a ride in the ballast water of ships. Okay. The problem is, again, when that ship is taking on cargo in the new port, then it's going to need to pump out that ballast water, right, because of the weight, the mass of the cargo it's taking on. So ballast water became a hugely important way that non-native species were spread across the globe, and it has become the most important vector or pathway by which invasive species were introduced into the Great Lakes. About 65% of all non-native aquatic species in the Great Lakes arrived as a result of ballast water mediated discharges from transoceanic vessels. Okay, so here's the thing, and keep this idea in mind for a bit. So when the cargo hold is full, this little graphic shows ballast tanks are empty. That's how I just explained it, except that's not true. It's impossible to pump out all of the residual ballast water. So even if a vessel is entering the Great Lakes system through the St. Lawrence Seaway, it'll be entering typically between 75% and 95% of the freighters entering the Great Lakes have cargo. They're bringing cargo to North America. They may be taking cargo back to Europe or Asia, wherever their home port was located. The problem is that they come in declaring a condition called, the acronym is NOBOB, so no bob ships, no ballast on board. The problem is, even though it's technically true that they didn't have their sea chest full of ballast water, there was still all this residual water. And what would happen is they would take on new ballast water and ultimately pump out the new ballast water, and it would mix in with that slurry, that kind of brackish, kind of salty slurry that was left in the ballast tanks. And it turns out that species that were tolerant, that have wide salinity tolerances, things like the Hemimysis anomalus, something that we call the bloody red shrimp, things like Hemimysis, or a lot of invertebrates have resting eggs, resting stages to their eggs that allow them to withstand desiccation, that allow them to kind of protect them from environmental conditions. When they're rehydrated, these organisms, they become viable, right? The eggs hatch, and the young are able to move into the new environment. So this became hugely important as the governments attempted to regulate this obviously important ballast water vector. I want to give you a couple of examples of some of the amazing organisms that were introduced into the Great Lakes via ballast water. Then I'll tell you a bit about what the government did, tried to do, and should have done. All right, so we'll start with if you're from Erie, Pennsylvania, if there's one invasive species that you know about, it's probably the zebra mussel or its close cousin, the quagga mussel. These are from the same donor region in Europe, the Ponto-Caspian region, Black Sea, Caspian Sea, Sea of Azov. And these were discovered in or about 1986 in Lake St. Clair, which is between Huron and Erie. And they quickly spread throughout all of the Great Lakes in a year. And they have been hugely problematic. So here's an example of the zebra mussels if you haven't seen them. There's a penny for reference. So these are not large mussels, mollusks. These are about the size of your thumbnail. They don't seem very impressive, but boy, when they get together, what they can do. So one of the unique aspects of zebra mussels, and this is unlike any native mussel in North America, at least as an adult, is that zebra mussels have these proteinaceous, sticky threads. They're called byssal threads. And it allows zebra mussels to grow on anything. And this makes them a biofouling organism. This is one of the main problems with, by the way, I use zebra mussels and quagga mussels interchangeably. They're different species. They have different ecological requirements, but just roll with me on that. So the zebra mussel, it has these byssal threads. It allows them to stick to rocks, but it allows them to stick to darn near anything, and that has become a huge problem ecologically and economically as they impact infrastructure, like, for example, drinking water intakes. So these are all examples. Zebra mussels were first found in or around 1986, and they're still here today. So here's an example of a monitoring buoy that my agency deploys in Presque Isle Bay each year. And here it is at the end of the season where it's absolutely coated with zebra mussels. One of the charming qualities of dry-scented mussels, means zebra plus quagga, is that they have, the smaller ones in particular, have razor-sharp shells. And as you're pulling this equipment out of the water, it can just slice your hand up. So it can slice, as these organisms grow on the shoreline, they can slice up the feet of bathers. So there's actually a physical risk associated with them. This is a small water intake pipe that's part of the Marina Lab, or what used to be the Marina Lab at Presque Isle State Park, completely clogged with zebra mussels, okay, decades after they were first introduced. They have no qualms about growing on other organisms. So these are zebra mussels growing on a native, we call them unionid mussels. So what happens is the zebra mussels will colonize or infest the native mussel to the point where the native mussel can't open its shell, its valves, in order to respire and to feed. And this will ultimately lead to the death of that mussel. So this mussel was dead and didn't even know it. That's a huge ecological impact in the Great Lakes, especially in a country where we have like 3 times the number of native mussel species as the entire subcontinent of Europe does. And here's an interesting example, not a great picture, but here we have these little things are zebra mussels, and they're growing on a bigger non-native bivalve called corbicula, or the Asiatic clam is the previous common name for it. So again, they really don't care what they grow on so long as it provides a suitable substrate for them to complete their life histories. So this is the most commonly known problem associated with the zebra and quagga mussels. Along with, perhaps you've seen, especially in the earlier stages of the invasions, maybe in the late 80s or the early 90s, windrows of these shells would wash up on the beach, and they're stinky and they're a nuisance, and I see some people saying, yep, we remember that. All right, so that's what's most commonly known about zebra mussels, and these are real problems that occur today. But sometimes the zebra mussels and quagga mussels, sometimes they're referred to as the ultimate ecosystem engineers. And hyperbolic, but there's some truth to that. So the way a dry-scented mussel feeds, the way it makes its living, is it has one tube that sucks food in and another tube that excretes what it doesn't want, it siphons. And it's a little biological vacuum cleaner, it's a little biological filter. And one single dry-scented mussel the size of your thumbnail can filter about 1 liter of water a day. And when you multiply that 1 liter times the massive number of dry-scented mussels that exist in the Great Lakes, at the peak of the invasion, you had the entire western basin of Lake Erie, one of the 3 basins, the most shallow in Ohio. It was being completely filtered roughly every 3 days. Every 3 days. The entire volume of the western basin was moving through the bodies of dry-scented mussels. So they had huge, profound impacts on water clarity, on water quality, on the light regimes in the lake. They clarified the lake. Light penetrated to greater depths. Plants that couldn't grow now were able to because there was enough light for them. They brought phosphorus from the offshore areas to the inshore areas and promoted other problems. So they've changed an entire large freshwater ecosystem. So really profound consequences that were entirely unanticipated. They've also provided an important new pathway for contaminants that used to just be sequestered, that used to just end up being stuck in the sediment of the Great Lakes. Well, the zebra mussels, through their filtering activity, they were able to concentrate these contaminants down at the bottom where they live into their own tissue. And then little fishes, and we'll talk about one in particular, were able to eat the zebra mussels, and then of course the big fish eats the little fish. And what you see is that contaminants like PCBs, a lot of you are going to remember PCBs, polychlorinated biphenyls, they've been decreasing in our sport fish over time. And then you see a reverse of this trend as a result from these brand new biomagnification pathways that are facilitated by non-native aquatic invasive species. Who in the world would have thought of that? Back in the, I guess it was early 2000s, we call avian botulism. We were having these kind of bird and fish die-offs. They often occurred in the fall. It looks like zebra mussels and another non-native species seem to play an important role in this new, in this new avian botulism pathway as well. They may even be playing a role in the current phenomenon of increased harmful algal blooms in the Great Lakes. Because as it turns out, as they're filter feeding plankton out of the water column, they don't like some of the more harmful algae. They don't like things like the blue-green microcystis that produces toxins. So they spit that back out. So they're kind of taking preferentially the more palatable algae for themselves. They actually may be increasing some of the harmful microscopic cyanobacteria or plant species in the water. All right, so again, incredible, profound impacts, and they still exist to this day. All right. One thing about zebra mussels, they have a very unique life history. I mentioned the byssal threads that are kind of unique to dry-scented mussels. They also have another unique trait. They produce microscopic offspring larvae called veligers. This also is not what our native mussels do, but these veligers they can persist in the water column for between 2 to 4 weeks, and wherever the water flows, these invisible to our eyes microscopic plankton that are baby zebra mussels and quagga mussels will be distributed. So through outlet streams, for example, through bait buckets. If you're fishing and you've got your bait bucket over the side of your boat, and you pull it out at the end of the day, and you say, oh, I've got some bait left over, maybe I'll go fishing inland the next day or elsewhere. So you're moving not only your bait in the water in the bucket, but much like you're like a mini freighter with ballast water, you're also transporting all of the possibly invisible microscopic non-native invasive species that are in that water as well. So this is one of the reasons that zebra mussels spread so quickly throughout North America. They were unlike anything that the Great Lakes had seen before. They're often called the perfect invader. They're quite impressive. And the reason is that they occupy a niche that no other native mussel occupied. They kind of found the promised land. They had food, they had living space, and they had few predators. Life was good for the zebra mussel. It was less good when the round goby was introduced. This is another example of a ballast water mediated invader. Again, if there are fisher persons in here, you may know about the round goby. It's a small fish. It's from the same home region, the same donor region as the zebra mussels and quagga mussels. They're small. They don't grow to be very large. Maybe about 6 to 8 inches might be the absolute maximum size for the round goby. These are a small fish. They live on the bottom of the lake, and they are voracious predators. And most of the diet of the adult round goby are zebra mussels. So, what's unique, just so you know, in case you ever find one in your bait bucket, they can be identified, well, they're kind of have this, I've heard it described as pugnacious look to them. They've got a black blotch on one of their dorsal fins, soft dorsal fins, so they're not spiny, they don't jab your hands. If you're a predator, you're just happy. If you're a smallmouth bass, you're just happy to eat a goby. The problem is, if you're a goby, you're just happy to eat the eggs and the juveniles of the smallmouth bass. So it's a bit of an arms race. When the round gobies were first introduced, 1990, they were first introduced into the Great Lakes. We found them in Pennsylvania for the first time in 1996. The state of Ohio, they actually closed the smallmouth bass fishery for many years to avoid having round gobies invade the nests of our native smallmouth bass when they were caught by fishermen in the springtime and pulled off the nests. The males would guard the nests. You catch one, you pull it out of the water. I guess the moment that male was pulled off the nest, the round gobies would invade and just devour the eggs of the smallmouth bass. So, another unique characteristic of the round goby is it has a single, what we call pelvic fin. Actually, both pelvic fins grew together. No other native fish in Pennsylvania will have a single pelvic fin, so if you get a fish that kind of looks like this and has the black spot and one fin in the middle of its body, it's a round goby. Okay. So I mentioned that most of the diet of the round goby are the dry-scented mussels. There's a notion in invasion biology called a facilitated invasion. And the idea goes like this. One introduction of invasive species paves the way for the next introduction. So here you have two species from the same region on the planet. They evolved at the same time. So round gobies knew how to eat zebra mussels. These species were in balance in their native ranges. But now the dinner table was set both for the dry-scented mussels with all the food and the open space in the environment in which to proliferate. And then you have this ready-made food source that the round gobies had evolved knowing how to deal with, how to eat. So the notion was, do round gobies do so well? In part because of the previous invasion by the dry-scented mussels. The fact that they eat the dry-scented mussels, the zebras and quaggas, also is a large part of the reason for this new biomagnification pathway or new contaminant pathway or disease pathways. So if one species can facilitate an invasion, over time, there was a notion by a colleague named Anthony Ricciardi, and I have a citation to his work at the end of the presentation. But his thought was, have the Great Lakes been so weakened by these historical invasions that future invasions are more and more and more likely for similar mechanisms, kind of setting the dinner table, if you will, paving the way, disrupting the stability of the native ecology. Does that in some way benefit future introductions? And some data would suggest perhaps it does. I mean, here you can see the three different waves of invasions, and by far, the rate has been increasing, and one primary reason is the ballast water mediated spread of non-native organisms. Okay, this graphic, what I want to show you is that 65% of all introductions, and certainly the majority of recent introductions, are a result of the ballast water pathway. So I want to talk to you a little bit about what's been done. So I just scratched the surface, I think, of what I personally find to be some of the more interesting / detrimental, problematic invasive species in the Great Lakes. These problems persist to this day. Notice that I have yet to say, and this is how we eliminated that species, and this is how we dealt with that problem. It's incredibly difficult to deal with the consequences of a new species once it's introduced. Unlike chemical pollution that can sometimes be cleaned up or dissipates, life finds a way. Organisms reproduce. They increase in number once they're introduced into a new range. So it's not all gloom and doom. There have been some very significant progress with respect to invasive species management in the Great Lakes, and I wanted to touch on that. First of all, even though you noticed, if you were paying attention, the 3 waves of invasions, the invasion rate seems to be increasing. That seems to have stopped sometime around 2006. And Ricciardi and his colleagues have a hypothesis, they have an idea as to why that is. So, recall that ballast water mediated invasions, the zebra mussels, they were first observed in 1986. It's likely that they invaded Lake Sinclair prior to that. But about 6 or 7 years later, in response to the zebra mussel invasion, we had a new law in the books. And part of it was requiring ballast water exchange before freighters would enter the St. Lawrence and into the Great Lakes. So since 1993, ocean-going vessels were required to do what's called open water ballast exchange, at least 200 miles offshore. And the idea is the salinity of the ocean water would be lethal to the freshwater or kind of salt-tolerant organisms that may have been picked up in the home ports in Eurasia. The problem is that there was a major exception to, well, there's 2 major exceptions to the 1993 rule. The first is that when you are exchanging ballast water in the open ocean, under certain conditions, that can be very unsafe to the vessel. So if the ship master determined that it was unsafe to conduct an open water ballast exchange, they didn't need to do so. The second problem, and I've mentioned this earlier, was that most ships come in loaded with cargo and they declare no ballast on board. But hopefully you recall that there still is that residual ballast water in the ballast tanks. It's physically impossible to pump it all out. So this didn't seem to do the trick. So finally, as a result of ongoing invasions and meetings in the Great Lakes panel and people like me harping that, hey, we have a problem, it's getting worse, not better. In 2006, thank you Canada, they decided that no-bob vessels were not exempt from ballast water exchange. So they either had to exchange ballast water, even if they're declaring no ballast water on board, or they simply had to hold it in the ballast tanks and not discharge it once they entered the Great Lakes. And there was a very effective enforcement regime that went along with this, inspections in the St. Lawrence Seaway, I think nationally by the Coast Guard organizations. And this just may have done the trick. Okay, huge federal investment. There's been a huge federal investment in invasive species management and control. In the Great Lakes alone, there's been, my gosh, I lost track of the dollar signs, but billions and billions of dollars devoted since 2010 just for aquatic invasive species management. So a huge influx of money has been thrown at the problem. And in part, as a result of this problem, Pennsylvania has become invested in invasive species management. I've got to be honest with you, our state, the Commonwealth, has not been a leader in invasive species management. I know this because of working with my colleagues in the 7 other Great Lakes states and 2 provinces. Now we have a state invasive species council. I represent my agency on that council. We meet quarterly. A lot of good things have happened as a result of having that attention in Pennsylvania. The Department of Agriculture in Pennsylvania passed a new noxious weed law. Even though I'm a fish guy and talk about fishes, there's been a lot of progress to regulating, managing the transfer of noxious weeds, invasive plants in Pennsylvania. The Pennsylvania Fish and Boat Commission, lots of biologists work for the agency. For various reasons, even though they had primary regulatory authority for managing aquatic fishes and aquatic plants and aquatic invertebrates, they hadn't devoted the resources to do so. They finally have a full-time person devoted to doing just that. That's something that I was so gratified to see. It's something I've been lobbying for over the course of my career. So these are all good things. I don't want to say it's all gloom and doom, even though the species persist, I think that we're definitely moving in the right direction. And there have been scientific advances that have made management of aquatic invasive species much more effective, and I won't say more about that right now. There are still challenges, there's still some problems. Here are the problems that I still see. New invasions are still occurring, so things are getting better. The invasion rate has slowed. The invasion rate is not zero. We still have room to go with respect to ballast water management. With few exceptions globally and none that I can think of in the Great Lakes, we have not been successful in eradicating a problematic invasive species once it's become established. It's incredibly difficult to control, let alone eradicate, a species once it gets a foothold in the environment. That may be changing in the future. There are some new genetic technologies that are interesting and promising and a little bit frightening that could allow us to actually eliminate some species, but that's for another lecture. And ballast water regulations, even though the 2006 changes that required the NOBOBs to do the ballast water exchange, they're probably not enough. One problem is that I've talked about the invasions into the Great Lakes, so you can think of the donor regions, the source regions where these species have come from. The Great Lakes are the recipient region. Down the Great Lakes are now the donor region to inland water bodies throughout North America. If you don't believe me, think about the fact that despite massive federal effort to keep the zebra mussels and quagga mussels from crossing the continental divide, they have done so, and they now occur, throughout the Colorado River. They have to be managed in Lake Mead and Lake Powell. This is where water, unlike in the Great Lakes, where water is abundant and plentiful, this is a precious, scarce resource. So they're very, very serious about trying to prevent the ongoing spread of dry-seeded mussels and other invasive species in the western US. And I talked a lot about the ballast water exchange problem with freighters. Once the organisms are in the Great Lakes, are lake freighters that typically operate only within the confines of the Great Lakes. They move iron ore, taconite, and limestone, and sand, and other commodities, from port to port in the Great Lakes. They actually have the ability to transport vastly more ballast water than the ocean freighters do. The Lakers are designed, they're huge vessels. They carry a lot of ballast water because it's required, and they can pump that water on board and off board more quickly than the ocean-going freighters can, for economic reasons. Also, there's been a lot of work to install some sort of a technological treatment system on freighters to deal with ballast water. What works for the ocean-going vessels, for a variety of reasons, some of which I don't fully understand, don't work well for the lake freighters. Plus, it's of course costly to install a treatment system. So we don't have treatment systems installed in the ships yet. We don't have performance standards. We don't have limits on what sorts of numbers, quantities, concentrations of aquatic invasive species that can be discharged. And I think that's room for improvement still. Oh, regulations, I mentioned regulations. Just that our regulations have been delayed by decades in the United States. It's a dance between the Coast Guard and the Environmental Protection Agency, with the Coast Guard having a lead. We've yet, although these many years since the introduction of zebra mussels into the Great Lakes, we still don't have comprehensive regulations in this country to manage ballast water discharges. And of course, the Great Lakes are now donors. Okay, the problems haven't stopped. We still have canals. We still have interstate commerce. We still have recreational use of the waters. These are good things. But again, we still have the risk that's associated with those activities. And on the horizon, with some genetic detections in the Great Lakes, recently in Presque Isle Bay, we have the big-headed carps, what are formerly known as Asian carps. Now they're just referred to as invasive carps. There are a lot of invasive carps. They're biologically very dissimilar. But the big-headed carps, like it's called the big-head carp and the silver carp, hugely problematic. They have the potential for untold ecological impacts. They have the proven ability, this is not hypothetical, it's not biologists screaming fire, fire. They've eliminated commercial fisheries where they occur in the Illinois River. And there's a lot of concern about the invasion of these species as they swim upwards through the Illinois River, through an interconnecting waterway system in Chicago to Lake Michigan. So we still have things to worry about. I'm long-winded here, but we did start a little bit late. So let me just share what I think are the take-home lessons from this talk. First, the words matter. You'll notice I've been trying to be a little bit careful about the way we refer to the common names of these species, just because in this age of polarization and xenophobia, I don't think it's helping our cause anymore, to sensationalize and be insensitive about the way we refer to these species. Prevention is still the best line of defense. So another question that I sometimes get, sometimes by colleagues in higher places, is what can we do? What can we do? I can take, you're probably all good stewards of the environment. You're interested in things like this, that's why you're here. But you may take every precaution to not move species from place to place, but you know that other people don't have that same consciousness or ethic. So the question is, why should I try, if someone else is going to just move the same thing anyway, why should I spend the effort cleaning my boat or equipment or whatever it may be? Because not every invasion is successful. So there are multiple introductions that are likely required for the establishment of a new species in the environment. It's unlikely that the first discharge of ballast water that had zebra mussel veligers in it led to an establishment of that species. But as introductions are increased, it's what we call propagule pressure. The propagules could be the number of fertilized eggs in the water column. It could be the number of times you put the goldfish back into Lake Erie. The more times that happens, the more likely it is that those species will become established. So there is good, scientifically defensible reasons to make those efforts. The effort that you make may reduce the pressure to the point where there's not a new establishment. Okay, once they're there, they're hard to get rid of. I think I made that point. And they're incredibly difficult to control. Hopefully, from most of the slides, I said, and that species is still there, because they are. Okay, and ballast water regulation appears to be working. The ballast water exchange seems to be pretty effective, at least for slowing the new introductions into the Great Lakes. We still have concerns about the rate at which species are transported and mixed once they're in the lakes. Oops, I'm sorry if I keep shooting you with a laser. Okay, so I'll make this presentation available. I know it's being recorded. I've got links to some of the research that I use to base my talk upon. Some really good stuff by Ricky Yardy and McIsaac out of Canada, out of McGill University, Sturdivant and her colleagues with Michigan State University and NOAA. And Michigan State University has done a lot of good work about talking about the way we think about and name and refer to these species. And if you want to chat about invasive species or other interesting issues in the Great Lakes, give me a call. And that concludes my presentation. Thank you so much for your time and attention. It was an honor to be here today. I appreciate it.